to get logged in. Presentation, is everyone able to see that? Okay, can we see my my PowerPoint slide here? Okay. All right, I think so. All right, I think since we're recording, anyone who wants to catch up can watch. First, I'll introduce myself. I'm Matthew Tennyson. I'm a professor at university, and I'll give you a little bit of background. I've been at Murray State for about 5 years. Before that, I was teaching. Before that, I was an engineer at Caterpillar. I did embedded systems design and electrical or various machines. Type of machine I work with, so the machines we commonly refer to as backhoes. That's what I worked on. So I got my bachelor's degree in computer engineering from Rose Technology. I got my master's degree in computer science from Bradley University, Southeast, which is, I was living in, when I was teaching Peoria, Illinois. It was actually when I was teaching at Bradley University that I got my PhD. The Southeastern is actually down in Fort Lauderdale, Florida. But at the time, I think programs like this now, but at the time, it was the only program that offered through a distance program, a distance learning program. So I was able to live in Peoria. So I did have to travel a lot. I traveled down there 4 times a year to take exams and give presentations, and but that's how I got my. And now I'm a professor. And I'm actually the computer science program director. My presentation is on introduction to programming. I think in hindsight, the better name might have been a perspective on education, maybe. But here's the agenda. I'm going to talk about the state of computer, talk about introductory programming courses and introductory programming sequences and how college courses. I'll talk about resources for computer science educators, the opportunity about computer science at Murray State as well at the end. Have a wide variety of people in the audience, so a lot of you probably computer science education and types than I do. So hopefully it will. So first thing that I want to start with was short answer is the slightly longer answer. Bullet points here that came from code.org that I think will back that up. All new wages in the number one source of all new wage occupations. They make up, computing occupations make up over half of all projected. Here a couple slides later that will illustrate that graphically. And everything, right? My refrigerator has a computer. Everything has a computer nowadays. We all carry this all the time. So computers are ubiquitous. Computing is ubiquitous. computing supports all the other fields. Yes, of course. And what about Kentucky specifically? The same web.
Hey, Karen. Good morning.
Currently has over 5,000.
I've just got this thing running, and it's real boring. I've just got it off the sound off.
Oh, well, I didn't want to interrupt.
No, you're not interrupting, because if it's not any good, but I can't get anything out of it, I just let it run.
Yeah. Can we mute the microphone? All right, let's see how it goes. So in Kentucky specifically, right now, Kentucky currently has over 5, which is 3.7 times the average demand rate in Kentucky. There are over 3 times Kentucky. The average salary for a computing job in Kentucky is, and the average salary in the state is 43,000. Kentucky only award 581 bachelor's degrees in about 30 of those were from Murray State University. So people to fill the open jobs that we have in Kentucky. That's what that means. I will illustrate that a little bit more. And this is a quote from this document. Programs in Kentucky did not graduate a single new teacher prepared to teach computer science in 2018. Or not, that's a quote. It came from this fact sheet from code.org. That really stood actually. This fall, I'm going to talk with our education college what we might be able to do to remedy that, to at least start a discussion. Maybe create a computer science education major or something like that. So here's a slide, a graph, some of those things that I've been talking about. Now this came from Calvin College, but they pulled their data from, as well as the National Science Foundation. So this shows the total U.S. STEM through 2022 versus recent college grads. So, the number of jobs that are projected to be available, and the orange bar shows the number. So in computing, engineering, physical science, life science, and math, the only one that has looking for a job is there are more jobs than those jobs, and that's exactly what we were talking about from the previous slide. That's that. This is looking nationwide, but we have this issue in Kentucky as well. And you'll actually have the opposite ratio. There are more graduates than there are jobs. I want to go into if you want to find a good job. All of that said, that was all to to drive home the education. So now I want to turn to, well, what is the state of computer science education? And specifically, we'll look about college as well. There's a quote from this report. The both of those organizations later in a little bit more detail. This report was published a while. Admittedly, it's a little bit old, but I think we're still actually suffering the same now that we were then. But this quote summarizes the entire report. The report is 80 we can say, and this is a quote from the report, U.S. K through 12 education has fallen woefully behind. U.S. K through 12 students with fundamental computer science knowledge and skills they need for future success. The CSTA, in combination with code reports, and this is from the latest one in 2019, only 45%, so less than half, and courses still lack girls and underrepresented minority students. Sentence basically summarizes the state that we're currently in as of 2019. Hopefully, I drove home the point that computer science education is really important, that computer science is really important. Schools aren't even teaching it at all. In Kentucky specifically, teach computer science, so it's less than the national average. 28% of female students took I think what that means, I could be wrong about this, but I think that means 28% of male. I think that's what that means. 55% of all. So, but only 28% of the CS exam takers are 7% of underrepresented students took a CS exam. So I think this is we're in, and Kentucky I think is probably a little bit worse than the. And all of this data came from this report from code.org and the CS. Okay, so I just mentioned AP computer science courses. Already know this, but there are 2 computer science AP courses. One is computer science. The computer science principles course is science of computing and developing skills that computer scientists use. So it's a broad overview. So you talk about things like abstraction, and that's really heavily focused on programming, but you don't go real deep into it. You might talk a little bit about networking, but you don't go real deep into it. You might talk a little bit about information systems, but so it's a broad overview of a lot of different what computer science principles is, at least from my perspective. Computer science Java is the programming language used, and students learn to write programs. Current AP computer science courses. There are abbreviations that we use to talk about. I'm actually going to talk about CS1 and CS2 first, even though CS0 is listed for abbreviations that were coined by the ACM years and years ago, like 30 or 40 years ago when they first came out with their computer science. And they no longer use those abbreviations. The ACM doesn't. The abbreviations are still widely used when we talk about computer science education. So CS1 is when you enter college in a computer science program, and then CS2 is the second course. Basically, introduction to programming. In the current ACM guidelines, that should be taught, they list knowledge areas that should be covered. And knowledge area, which is abbreviated SDF, Software Development Foundations, and the that unit is basically what's typically covered in a CS1 course. It's Science A course, Introduction to Programming. So you learn basic syntax, semantics, variables, expressions, assignments, basic I/O. Oops. Would learn an Introduction to Programming course. then typically the second programming course at the collegiate level, and the non fundamental data structures. So you talk about array strings, stacks, queues, lists, trees. So those would typically be course 1 and course 2 in college. So I'm going to circle back to that. CS0 wasn't coined by the ACM. I think some researchers that were talking about computers abbreviation. And CS0 refers to a course that is a principles. So it's a wide range of computer science topics and principles. It's a broad overview of computer science and any particular topic, but you talk about computer science in a more at a principle level. And I think it's similar science principles course. Now CS0 at some universities is required for computer science students. Required for computer science students. Typically, it's offered as an elective for non to be introduced to computer science topics. It's a general education class at some universities. So it's sometimes required, but now there are lots of approaches that can be taken to teach introductory computing topics, and not all of them are programming first approach. Many of them are, but not all of them. Now, these are an old version of the ACM curriculum guidelines. They're still referenced in the latest guidelines, but they're not much detail. And these aren't exclusive either. There are other approaches and approaches. So this isn't like an exhaustive list. This is just a broad overview of taken to teach introductory computer science. I've listed them in order. ACM. I listed them in this order in what I think the objects first approach is the most common approach. So you teach object CS1 course, you would teach object-oriented programming. That's what I think most universities. Breadth first means you would take one of those principles courses first. You would get a broad overview of computer science before you particular. So those universities that require CS0 as their first course, they would be approach. Imperative first would be a programming first approach. You don't get programming, so you teach imperative based programming first, and you might get into object or algorithms first approach would be a pseudo programming approach where you just teach or flowchart. You teach about the mindset of programming without actually doing the programming. Algorithms and first. Functional first means you're teaching a functional language. How many of you are familiar with functional programming? But functional programming, there are certain languages that are based entirely. Everything in the program is a function, and you really don't have anything that's not a function. So functional programming languages that have functions. Functional programming languages are languages that only have functions. And Lisp or Scheme or Haskell, those are all functional languages. So if you use one of those languages, that in hardware first means you sort of take a bottom-up approach. You actually teach about the hardware first, abstract from there, and you would talk about programming later. So this is these are just some approaches used to teach introductory programming. And like I said earlier, I believe objects first or breadth first. The first three there are used in over 90% of all would. Okay, so it always comes up when we discuss introductory programming courses is what programming language to use. Language, Java is used in the AP Computer Science A course, and it's used at the college level as well. In a 2016 study, Siegfried by used about as often as all the other programming languages combined. So this table, I only that are in the table, but this is published in that paper. This is a list of all the languages on their survey responses. Those languages are used. So Java, you can see responses 180 times. Python is second at 76. Racket is a variation of Scheme, so that's a functional programming language. Drops down drastically. You have less than 4. You only have 2 or 1 respond. Commonly used languages in introduction to programming. Siegfried published a survey prior to this. Was way further down on the list than it is now, or it was in 2016. Visual languages like Scratch and Blockly, which don't even show up on this list, but I think another study today, Java would still be number 1, Python would still be number 2. I think you would also probably find a language like Scratch or Blockly on there as well. I haven't done the research, but I think that it would fall up pretty high on the list now. Here are some resources for computer science educators. STA, I've mentioned a few times already. They publish a lot of these reports on computer science education. Also, code.org. There's Computer Science Education Week, which is abbreviated CSED Week. That stands for Association for Computing Machinery. Let me go one by one. TA, what they do is they create a community that supports K through 12 educators. It's actually made up of K-12 educators. They try to create local communities, so they create chapters, local chapters. Anywhere and everywhere, potentially. In Kentucky, there are only 2. One is in northern Kentucky, Highland Heights, Louisville in northern Kentucky. So in southern Kentucky, western Kentucky, eastern Kentucky, Murray State is in western Kentucky. I'm actually going to look into what I can do about creating a chapter. Well, I think we need that representation here as well. Code.org organization dedicated to expanding access to computer science in schools. So they and underrepresented minorities and youth and groups. They provide curriculum. So if you just go to that website, code.org, you'll find all sorts of lessons in the classroom. Lots of things are just done online. So they have games. You play these games, but you're learning to program at the same time, and you're learning to think. So that's a great website. I even use it in when I teach the CS0. One, I would not be, I don't know that I ever have, but I certainly would think about incorporating website in a CS1 course as well. They also organize the annual Hour of Code campaign. So if you are computer science teachers, you've probably heard of Hour of Code. It's a big campaign. Students sitting in front of a computer and coding for an hour, doing whatever it is, as long as it's related to coding in some way. So they have a lot of information about that on that. Education Week, actually, the Hour of Code campaign. Computer Science Education Week is larger than just the Hour of Code, but Hour of Code is. It's always held during the week of December 9th. It's in honor of Grace Murray Hopper, who was a pioneer computer science, which COBOL, which was one of the very first programming languages back in the 50s, still widely used today. Millions and millions and millions of lines of code that are still running our. The ACM, which stands for Association for Computing Machinery, world's largest computing society. So it brings together educators, they publish journals and magazines, they sponsor conferences. They're the ones that develop the CS guidelines several times already. The ACM is really the society. There are 8 chapters in Kentucky. They're all university as well. I'm the faculty advisor for. Yeah, so I'm the faculty advisor chapter at Murray State. Switch gears. This is where I'm going to propagandize a little bit about Murray State. I'm just going to talk about computer science. These are the majors that we have that are directly related to computing. We have computing. We also have concentrations in game development and data science. Game for young people to get into computer science. So a lot of people game development. We also have a computer information systems major, which it actually is a business. It's considered a business degree. So it's so you have to take all of the foundation computing classes on top of that. The computer science and the CIS majors are at which is my department. And then we have a cybersecurity management, which is abbreviated CNM. And in that major, we have cybersecurity, wireless administration options. So this is more like hands-on technical work. If you wanted to be a systems administrator or a network, and you could have that major. This was formerly known as TSM, so I don't know. They just changed their name. We're still in that transition now. This was formerly communications, but now it's cybersecurity and network management. Computing related, but they're more tangential. Graphic communications, engineering, engineering physics. We have mechanical, electrical, and aerospace. We're also discussing the possibility. That's still in discussion. We also have an electromechanical engineering technology. So that would be a good major for you. So these are all the majors we offer that are. We have other programs. We have minors and we have master's programs and we have certificates. You can get a minor in computer science. You can major in history or art or anything that you wanted to, music. And then if you wanted to stick around for a year and a half or 2 years after your bachelor's degree. We also have lots of student organizations related to computing. We have an ACM. It's basically the Computer Science Club. We have AITP, which is basically the CIS Club. Technology Club. We have a ATSM, which will probably be rebranded now that the major CNM, that'll probably change as well. I also have a Game Lab Math Club and Science Fiction Club. club because the advisor is in our department, not because it's necessarily computing related. This is what a freshman year would look like if you were a computer science major. Fall and spring semester. These are course numbers, and I know that doesn't mean anything to me, but this is a freshman transitions class, just like introduction to college life and an overview, advising and things like that, all the clubs, and it's a kind of an informational thing for CS 101 is a CS 0 course, and if you get credit for our CS 101. So we're actually a breadth first university. This CS 101, CS 0 course, get a wide, broad overview of. And 5 is our intro to programming, and we use Java as our first language. So this is equivalent to AP Computer Science A. So if you score high enough on the exam, and get credit for that. 35. This is statistics, and this is just English composition. This is just a typical. And then Math 250 is calculus. So we prepared to take pre-calculus at least. If they score low enough on the ACT or a math placement exam, they might have to take algebra. We expect them to come in with, and most students do come in with, basically pre-calculus. So they'll be ready to take calculus at the collegiate level. But of course, if they take, they would get credit for calculus as well. So that's a case-by-case basis. Every student. Okay, so but that's what a typical freshman year would look like in terms of coursework at Murray State. Typical for most universities. If you want more information about computer, you can look at our website. We have some Facebook pages, one for the ACM, one for our department. Murray State, of course, talk to it if you know of a prospective student who is interested. So that's all that I have. I do have a lot of supplemental, or you want to talk about anything? Okay, I see there's some chatting going on here. Yes, so AP Computer Science Principles counts as our CS 101. The AP Computer Science A course counts as our CS 145. Okay, so there's going to be another presentation about CSTA later. And it sounds like it's not very active currently, the Kentuckiana chapter. So maybe that'll. The score needed, I think that's referring to the AP exams. I think you need a 3 or higher. It's not my purview, that's actually admissions, but I believe they count a 3 or higher. So we would not accept a non-AP course as credit. I mean, you have to take the AP exam and score high enough in order to get credit. AP exam and scored high enough. But if you feel that you know the principles, we have credit by exam. So you can actually and prove that you know the material, and you can test out of. So if you took a Java course in high school, but it wasn't an AP course, and you didn't take an AP exam, perhaps get credit for CS 145. I apologize for the audio. I guess that's from my end. I'm not sure, but I apologize. I have a good connection here, or something else is going wrong. I think I answered all the questions that came through chat. Is there anything else? I think we still have some more time, so I have some supplemental slides, and I'll just talk on questions or points of discussion. I'm going to keep going then. I'll keep going until my time is out. So been introduced at the very beginning, just what is computer science. Audience, I think probably some of you teach computer science already. Some of you might not teach computer. I don't know. I know there's a wide variety. So we could start study of data structures, their algorithms. So an algorithm. So so when you encounter and some of those solutions we can actually implement on a computer. So it's a sequence of instructions that we tell the computer to execute. That's what a program is. So an computer program. But it's data, it's how we store data, it's how we solve problems. So we're talking both hardware and software. Computer architecture usually refers to hardware. Algorithms are their solutions to problems, and that's what algorithms, the study of problem solving, their design methodologies. How do you come up with efficiently, right? It's not just solving, but it's finding the most elegant problem. And when we talk about efficiency, we're talking about time and space. In a short amount of time, and you want to solve the problem with very few resources. So problem solving, design methodologies, language design. Now that can be programming language design, but some of the pioneer computer scientists that designed early actually linguistics experts. They actually studied knowledge of natural languages to design programming languages. So there's a video here. I'm not going to try to play it, but this is published by code.org. It's entitled "What Most Schools Do About Coding," and there's a lot of famous people in there that gets young people interested in it. I talk workshops for high school students. Science Education Week. It's always the week of December 9th. It's by Congress, by U.S. Congress, and it's always the week of December 9th. Talked about her earlier. She created the COBOL language. She was an early teacher of computer science and math. December 9th is her birthday, so that's why it's always the week of December 9th. So the point of that week is to I think the biggest thing to come out of Computer Science Education Week was Hour of Code. Usually around December 9th during Computer Science Education Week, and and it's just to get in front of a computer actually doing coding work, and getting them interested and getting them excited. If you go to code.org, you'll find lots of things that you could use for Hour of Code. Sort of puzzles or games of programming problems that you can solve, and plans for. And now there's all sorts of things. I mean, anything you can imagine, any kids movie or kids show that you can imagine, to create themes and just to create interest in young. So for this, I did this a few years ago. I created this slide. Indeed.com, and I just typed in computer scientist, and I just copied and pasted lots of. This is just a sampling of different job titles that you can, or jobs that you can. So you have SCM is software configuration management. So managing software, managing versions of software, network analyst, Java developer, help desk specialist, iPhone developer, game design engineer, software stuff. There are a few here like technical writer. You know, people probably do computer science degree, but you can't. We need people to write technical manuals. Computer science degree, or you could be a teacher. Pay, experience level. Now this is from a different source than what I quoted earlier, but according to this source, less than a year, you would expect about 63,000. Years it was up to, you know, six figures, over 118,000. So you can kind of see what the by experience. So it's a real salary range. These are more specific job types would be. So software engineer is a really job for computer scientists. 125K for that job. Software developer, senior software engineer, you can just see salaries would be. On this particular list, you can see web developer is the lowest salary, from 40K to 87K would be the expected. You know, we have computer science jobs in Murray, Kentucky. So you're not going to expect to on the high end of these ranges, 50,000 or 60,000 in Murray, Kentucky, even a small town like this. But start, you shouldn't expect something like 80,000 or something. So this is very location dependent. Likely you are to be paid a higher salary. Math is a big issue for incoming students. Depending score or a math placement score would the course you needed to take as your if you got an ACT math score of less than 18, you're going to have to take some foundational classes, fundamental math. You work your way up. You would take 110 and then 140 and then 145 and go on from there. And in 20, you would start out with a college algebra class, but you would have some review built in for review. And then if you were between 20 and 22, you'd start out with college algebra. Basically pre-calc, it's algebra and trig combined. And then over 25, you can start with calc. AP calculus, and you scored well enough on the exam, you could get credit for that. Gaming is a big thing that we have. We have a game development, and we have a lot of interest from students about our gaming courses. So these are some of the courses that you would take. But you would take Intro to Game Programming, Advanced Game Programming, Graphics, AI, Graphic Design. Those are some of the courses that you would take if you went through the game development program. This is the end of my supplemental slides. If any of the chat, and we're about out of time. This is actually pretty good timing. Does anyone have any questions or comments? Okay, I don't see anything coming through and I don't hear anything, so I'll end it there. Thank you all for attending. All right, thank you.